the Science and Technology Conference of the CTBTO for 2017. And our panel discussion today is on advancing the Comprehensive Nuclear Test Ban Treaty with science diplomacy, learning from the past to enable confidence building across scientific communities. We have a very distinguished panel, and I will introduce them in the order in which they will speak. So our first speaker is Dr. Anatoly Dyakov from the Russian Federation. He's professor of physics at the Moscow Institute of Physics and Technology, commonly known as MIFI. He's the founding director of the Center for Arms Control Studies. He has written a number of papers on nuclear arms reductions, the history of Russia's plutonium production, disposition options for excess plutonium, as well as the feasibility of converting Russia's fleet of icebreakers that run on highly enriched uranium to power their nuclear ship propulsion reactors to run on low enriched uranium. And finally, among other accomplishments, he's also a member of Princeton University's International Panel on Fissile Materials. He will then be followed by Dr. Jonathan Foreman from the United States of America. He's Science Policy Advisor and Secretary to the Organization for the Prohibition of Chemical Weapons Scientific Advisory Board at The Hague in the Netherlands. He holds a PhD in chemistry from the California Institute of Technology. He has worked for a series of biotechnology companies developing molecular diagnostic and bioanalytical assay technologies for genomic immunoassay and cell capture applications. He's also an independent consultant for process and product development of chip-based assay platforms. He will then be followed by Dr. William Potter, director of the James Martin Center for Non-Proliferation Studies in Monterey, California. And those of you who were here a couple of days ago at a youth group forum meeting, you heard a number of them acknowledge Dr. Potter's contribution to promoting disarmament and non-proliferation education, and actually he is the founder of that particular concept and promoting learning among young people. He is the Sam Nunn and Richard Lugar Professor of Non-Proliferation Studies. He's the founding director of the Center for Non-Proliferation Studies, a member of the Council on Foreign Relations. He served on the International Advisory Board of the Center for Policy Studies in Russia. He also served in the United Nations Secretary General's Advisory Board on Disarmament Affairs, and he has attended every Non-Proliferation Treaty Review Conference meeting, as well as its preparatory committee meetings, starting from 1995 as a delegate of Kyrgyzstan. And our last but not least, the final speaker is Satara Noor from Pakistan. She recently finished a research fellowship at the Vienna Center for Disarmament and Non-Proliferation. Prior to joining the VCDNP, she worked at the Pakistan Nuclear Regulatory Authority in the Directorate of Physical Protection and Nuclear Security. She's also been a lecturer in the Department of International Relations at the National University of Modern Languages in Islamabad, and a visiting faculty member at the Information Services Academy and the Pakistan Foreign Services Academy. So our session today deals with the role of science in promoting confidence-building measures. And I thought I would show you two short videos. The first shows how politicians get advice from scientists and then convert it into political advantage for themselves, regardless of the science. And the other following video is a very short clip as well of how the scientists take over in terms of developing new technologies, which puts the politicians or policymakers in a difficult situation. So the first video is from a BBC series called Yes, Prime Minister, and I will just show you 2 or 3 minutes of that. And the second one is from Dr. Strangelove.
Drink might be wiser. Better not to let the Cabinet Office know. Sir Humphrey gets very upset. He doesn't regard the Chief Scientific Advisor as one of us.
I thought he won the DSO, darling.
That doesn't make up for speaking with an Austrian accent. He certainly didn't go to Oxford or Cambridge. He didn't even go to the LSE.
Prime Minister, you do believe in the nuclear deterrent.
Oh, yes.
Why?
A big one?
Why?
Because it deters.
Whom?
A big one?
Whom? Whom does it deter?
Well, the Russians from attacking us.
Why?
A big one?
Why?
Because they know that if they were to launch an attack, I'd press the button.
You would?
Well, wouldn't I?
Well, would you?
Last resort, yes. Yes, I certainly would. Well, I think I certainly would, yes.
And what is the last resort?
If the Russians were to invade Western Europe.
But you only have 12 hours to decide, so the last resort is also the first response. Is that what you are saying?
Am I?
You don't need to worry. Why should the Russians annex the whole of Europe? They can't even control Afghanistan. Now, if they try anything, it will be salami tactics.
Salami tactics.
Slice by slice. One small piece at a time. So will you press the button if they invade West Berlin?
It all depends.
On what? Well, scenario one. Riots in West Berlin. Buildings in flames. East German fire brigade crosses the border to help. Would you press the button? The East German police come with them. The button. Then some troops. More troops, just for riot control, they say. And then the East German troops are replaced by Russian troops. Button. Then the Russian troops don't go. They are invited to stay to support civilian administration. The civilian administration closes roads and Tempelhof Airport. Now you press the button.
I need time to think about it.
You have 12 hours.
Have I? You're inventing this.
You are Prime Minister today. The phone might ring now from NATO headquarters.
Hello, yes. NATO headquarters.
Okay, so that's enough for that one. And let me see if I can get the other one going with another couple of.
When it is detonated, it will produce an unlethal radioactive fallout so that within 10 months, the surface of the Earth will be as dead as the moon.
Come on, Satsky, that's ridiculous. Our studies show that even the worst fallout is down to a safe level after 2 weeks.
You've obviously never heard of Cabal Thorium-G.
Well, what about it?
Cabal Thorium-G has a radioactive half-life of 93 years. If you take, say, 50 H-bombs in the 100 megaton range and jacket them with Cabal Thorium-G, when they are exploded, they will produce a doomsday shroud, a lethal cloud of radioactivity which will encircle the Earth for 93 years.
What a load of commie bull. I mean, after all.
Afraid I don't understand something, Alexei. Is the Premier threatening to explode this if our planes carry out their attack?
No, sir. It is not a thing a sane man would do. The doomsday machine is designed to trigger itself automatically.
But surely you can disarm it somehow?
No, it is designed to explode if any attempt is ever made to untrigger it.
Automatically?
It's an obvious commie trick, Mr. President. We're wasting valuable time. Look at they going. They're getting ready to clobber us.
But this is absolute madness, Ambassador. Why should you build such a thing?
There were those of us who fought against it, but in the end we could not keep up with the expense involved in the arms race, the space race, and the peace race. And at the same time, our people grumbled for more nylons and washing machines. Our doomsday scheme cost us just a small fraction of what we've been spending on defense in a single year. But the deciding factor was when we learned that your country was working along similar lines, and we were afraid of a doomsday gap.
This is preposterous. I've never approved of anything like that.
Our source was the New York Times.
Dr. Strangelove, do we have anything like that in the works?
A moment, please, Mr. President. Under the authority granted me as Director of Weapons Research and Development, I commissioned last year a study of this project by the Bland Corporation. Based on the findings of the report, my conclusion was that this idea was not a practical deterrent for reasons which at this moment must be all too obvious.
Okay, so you get the point, and in the first case, the politician is trying to get advice from the science advisor who's leading him through various policy options, and the politician finds that he is unable to reach a rational decision. And in the second case, the scientists have come up with a technology that they feel is necessary for national defense, and the political leadership is finding out about it, and then they will have to deal with the situation. Anyway, we will now listen to our 4 distinguished panelists. We have agreed that they will each speak for 10 minutes. After that, we will have a question and answer session. And those of you who have downloaded the conference app, you can also transmit any questions you would like if you prefer not to stand up and take the mic. And those people who are watching on live stream, they can also send in their questions via the app, and then the questions will show up on the screen, and we will ask the panelists to respond to them as appropriate. So we can invite our first speaker, Dr. Yakov.
Thank you, Mr. Chairman. Good morning, everybody, and thank you all for coming to this session. My presentation about potential cooperation between American and Russian scientists aiming to advance the entry of the CTB into the force. 20 years have been passed since the opening of CTB for signing, but for known reasons, treaties have not entered in the force yet. Obviously, actions are needed that would facilitate decision by the remaining key countries whose ratification under the treaty terms is necessary for its entry into the force to ratify the treaty. According to many experts, the ratification of the CTB by the United States can clear a way for ratification of the treaty by China, and this could radically change the situation with entering treaty into the force. The motivation for which the United States Senate refused to ratify the treaty in 1999 are known. They are mainly due to the doubts about the possibility of an adequate international verification of the treaty obligation compliance, and doubts about ability to maintain safety and reliability of the nuclear stockpiles without testing. And it seems the only way to bring of the CTB into the force is the cooperation, and first of all, the cooperation among specialists in those areas that cause the greater fears or doubts. In the past, the cooperation between Russian and American scientists helped to advance the ratification of nuclear testing agreements. An example of this is the so-called joint verification experiment. The joint verification experiment took place in 1998, and it was a central part of the nuclear testing talks between the Soviet Union and the United States in completing verification protocols for the Threshold Test Ban Treaty and the Treaty on Underground Nuclear Explosion for Peaceful Purposes. These two treaties have been negotiated and signed in July 1974 and in May 1976, respectively. But they did not enter into the force for more than a dozen years because there was concern, mainly on the United States side, that 150 kiloton limits might have been exceeded in the test carried out after the signing of the treaty. In accordance with the treaty provisions, to verify the treaty's obligation, each side used only initial technical means. At that time, it was only seismic monitoring techniques. The accuracy of the seismic methods for determining the yield of the nuclear explosion depends on knowledge of the properties of the seismic wave propagation path, as well as geological characteristics of the test sites. It is known that in hard rocks, most of energy of the explosion goes into the seismic wave, and the porous rocks much lesser. The higher amplitudes from the symbiotic explosion generated suspicion on the American side in violation of compliance requirement of the treaties by the Soviet side. The GVE was designed to choose and calibrate verification methods for estimation yield of nuclear explosion. To improve verification capabilities, both sides agreed to arrange a meeting among Russian and American specialists. By the way, it was the first time when Russian and American scientists gathered for the work together. As a result of consultation, it was agreed that each site would conduct a nuclear test at its own test site, while inviting the experts of other sites with their agreed equipment in order to calibrate verification methods for estimation of explosion yield. To measure the yield, the US site has proposed to use the so-called hydrodynamic methods. But this method was impeded by intrusiveness, since the measuring equipment could allow access to classified information about the design of the nuclear device being tested. However, these and other technical problems were successfully overcome, and the joint work allowed to develop the agreement on the GVE test, which were successfully carried out at the Nevada test site on August 17, 1988, and 1 month later, on September 14, at the Semiratinsk test site. The verification methods that have been demonstrated, evaluated, and proved in these experiments have opened a way to signing so-called referendum agreement to the both treaties that put them into force of June 1, 1990. Along with the fact that joint verification experiment gave to both sides a great and unique experience to work together on common challenges and goals, it resulted also in mutual respect for the specialists on other sides. Important to note that this work laid out the foundation to the subsequent US-Russian cooperation on nuclear security issues within the frame of the CTR program. During the period from 1992 to 2014, Russia and the United States are actively and effectively cooperated on the nuclear issues and achieved much primarily in the field of nuclear security. As a result of work under the CTR program, along with a dramatic reduction of nuclear threat, a vast and unique experience in resolving political, legal, and technical issues was accumulated by the governmental agencies and nuclear laboratories in both countries. The specialists and managers of both sides found a way to work effectively on some very sensitive issues without compromising national security of their countries. One of the most important results of this cooperation was the establishment of personal contacts and mutual understanding between Russian and American specialists. So now the question is, how can we expect that the cooperation of American and Russian experts can contribute to the ratification by the United States of the CTB by conducting joint research aimed at minimizing concern associated with the ability to maintain safety and reliability of the nuclear stockpiles without testing, and the ability to reliably monitor compliance with the CTB commitments. As for issues related with the reliability of the nuclear arsenal, taking into account that most activity here is pretty sensitive for both sides, the most anticipated answer would be no. However, this is not obvious if we will take into account the experience of their previous joint work in the frame of a lab-to-lab program, in such programs as exchange of technical information on safety and security of the nuclear weapons, conducting of a fundamental and applied research project on explosion physics, methodology of ensuring nuclear weapons safety, and maintaining nuclear weapons in working conditions. Experts from both sides even work together on such sensitive topic as modeling dynamic properties, phase transformation, changing the structure and strength of plutonium as a result of its aging. Based on this accumulated experience, the parties could continue joint research on study the feasibility of maintaining the existing weapons in safe and reliable state without conducting tests with energy release, regular exchange of information on experiments primarily carried out at the test sites without energy release, and explore the possibility of presence of Russian experts at the US Nevada nuclear test site during experiments, and accordingly, American experts at the Novaya Zemlya test sites in the period of such experiments. Concerning doubts related with the monitoring capabilities to detect, locate, and identify of nuclear explosion, the 2012 a study which was carried out by the US National Academy of Science. This study concluded that capabilities of the MAS and better capabilities of the US national technical means placing a constraint on nuclear explosion testing and prevents the development of new types of nuclear weapons. Nevertheless, more work is needed to better quantify regional monitoring identification thresholds, particularly in the region where seismic waves are strongly attenuated. The efforts of joint US-Russian scientific cooperation in enhancing of NAS monitoring capabilities would be focused on development of high-frequency regional and local seismic methodologies to lower thresholds for detection, location, identification, and characterization of events. Improvement of the detection evasive nuclear explosion testing, development of the seismic sources models to allow a prediction of potential explosion signals in untested complacement geometries and geologies, development of numerical modeling capabilities, coupling together sources and the propagation models.
Anatoly, would you please wrap up?
Just 1 minute more. Thank you. It should be noted that understanding of the necessity of cooperation between Russia and the US on the nuclear issues was quite clearly expressed by Russian and the American experts. In early June 2013 in Moscow was held the review conference on the results and experience of joint work on the various projects carried out within the frame of the CTR program. In concluding conference decision prepared by Russian and American scientific and technical experts who has directed the joint project, they noted the urgent need to continue mutually beneficial cooperation. Today, due to the differences, including those of Ukraine, Middle East, and other issues, cooperation between Russia and the United States has almost come to the standstill, and communication between nuclear and technical experts on both sides is frozen. But several circumstances compel cooperation between Russia and the United States. Let me mention just 3 of them.
Anatoly, you could deal with some of this in the Q&A. I think you made some of your key points about the joint verification experiment, which built confidence at the time. That
So
led
if you want,
to
I can just...
I think then, we'll just go over time. So if you don't mind, we will still have nearly an hour afterwards, so we can sort of fill in then. Okay, thank you. But I think the key point that Anatoly was making was the contribution of science to overcoming mistrust. And the joint verification experiment that he mentioned also built on nearly 20 years of work of a group of seismic experts that were working on developing the verification, the science behind the verification technologies. And as the executive secretary of the CTBTO now points out, the capabilities of the international monitoring system now are much beyond what was envisaged in 1996 when the treaty was signed. And so this, I think, is another area where science can help the politics of mistrust to help bring this treaty into force. Jonathan, you have your 10 minutes now.
I need 15 minutes.
Okay, slight technical difficulty, but all under control. So I'm going to start off in this. Okay, another slight technical difficulty. All right. Okay, I'm going to start off today where I left off in the presentation I gave yesterday, where I made the point that disarmament, to be effective, requires that you have effective scientist and policymaker collaboration. In the context of a chemical weapons convention and how that treaty is implemented, of course you need technical expertise for destroying chemical stockpiles and the types of tools and activities that inspectors take care of. But coming to the point of the presentation we just heard about building trust across communities and using that, science diplomacy if you will, as a way to build trust between countries, the two other aspects of treaty implementation become actually somewhat more important, even though they take a back seat in terms of their visibility. And these are countries being required to provide assistance and protection to one another in the case of a chemical incident, and also drawing upon scientific expertise to build international collaborations. And this is not just science for disarmament purposes, but science to get scientists working together, which has a trickle-up effect, if you will, of getting governments to take notice and see productive relationships being built across scientific communities. I mentioned yesterday that while we don't have 337 stations around the planet, we do have 23 laboratories in about 17 countries that form our designated laboratory network. They are designated to work on environmental or biomedical samples, and they provide a network of scientists from across these different countries that support the Chemical Weapons Convention. And what do these laboratories actually do? They do proficiency tests. In order to maintain that designation, every lab has to participate in a proficiency test once a year for the designation that they choose, environmental or biomedical, and they can only get one wrong answer in 3 tests in order to keep their designation. So sometimes they disappear from that map, and sometimes they come back once they reestablish themselves. They generate validated data that can be used to definitively recognize that a chemical agent has been used, was present, or its degradation products are present, including chemicals that are not some things that you would find commonly in a chemical laboratory or an industrial facility, but things that are truly chemical warfare agents. And they also publish their work in the open scientific literature, peer-reviewed scientific journals. And while this seems pretty obvious that if you're a scientist, you're going to publish your work, I think you can't underestimate the importance of this. And where this really comes into play is perhaps thinking about recent events. There may be at some point in time court cases where scientific evidence is being brought to trial to try to prove a point. Scientific methods that are peer-reviewed, coming from the scientific literature and validated by the scientific community, hold much more weight and validity under a court situation than somebody saying this is the technique we use and it's good. And it's really critical to get that visibility. And this also has another impact because it allows scientists to recognize across scientific communities what types of work people are doing and how it might be of interest to them, and it builds relationships. We have another scientific community that supports our treaty. It's our Scientific Advisory Board, 25 members from 25 different countries. They serve for up to 2 3-year terms, and they serve in an independent capacity. And the interesting thing about this Scientific Advisory Board, it's not something that was just decided to be done. It's actually in the treaty that says we should have this board, and this board should provide advice to the Director General. My understanding of the CTBT, although I'm no expert, is it actually has a similar provision that allows the Scientific Advisory Board, although as I understand it, it hasn't actually been activated at this point. And then there is Article 11, or in the Biological Weapons Treaty, Article 10. And this is using science for economic and technological development, basically chemical sciences to build capacity between countries. And this is very interesting because there's a lot of arguments about this with the delegations as to who's complying with this article and who might not be. And if you think about the value of this, it's a way to let us engage scientific networks. And think of the power of a scientific network. I showed this graphic yesterday. Every line on this chart represents a connection between two cities where scientists are collaborating, publishing papers, publishing patents across those borders, within countries, internationally, and this is all scientific publications between 2008 and 2012. So you can only imagine what this probably looks like now. And if you're really interested in who's collaborating with who, you can go to the Nature Index. They have this nice interactive chart that does all these cluster diagrams. It's probably 10 minutes isn't long enough to explain this, but if you want to sit down and play and see who's collaborating with who, these charts are amazing, because when I hear the arguments between the delegations about who's complying with these Article 11 and Article 10 and who's not, these charts sometimes support those arguments and sometimes they challenge those arguments in pretty interesting ways. Of course, to this group, there's no need to talk about the value of scientific collaborations. I think you have it demonstrated here. Now, I look at this from an outside view because I'm in a different treaty organization. And to me, one of the things that's really amazing here is that you have all these stations about science for disarmament, and what's coming out of it is science that captures people's imagination, that draws people that don't think about disarmament to come and be interested in working with the treaty. We don't actually have this in the Chemical Weapons Treaty, and to a certain extent in the Biological Weapons Treaty either, because there, when we talk about science, we have to reach out to the scientific expertise to get them to come to us, because when I'm working in a lab and validating mass spectrometry data for chemical weapons analysis, that doesn't really have applications to icebergs and whales and space science. So it tends to keep us in sort of a little niche, if you will. We do have programs to try to get more labs into our designated laboratory networks, a laboratory twinning program, matching labs in countries that are matching designated labs with labs in countries where they don't have a designated lab, but that still keeps you within that niche. We also have the ability through our scientific advisory board to form working groups where we can expand the number of experts. But again, we have to reach out to those experts and recognize that we want to bring them to us and have them support the work that we do. What's really important, and I can't emphasize this enough, is how do you recognize opportunities across disciplinary boundaries? Because to use science in a way to get people engaged, to find useful tools and capabilities for your treaty, you need to always be thinking about new things, be innovative. And I'll give you an example of that. How many people relate agriculture and farming to chemical weapons treaty implementation? If you don't, that's okay. I have a hard time arguing this with my bosses too. But nevertheless, a lot of really cool things happening in the farming industry. Drones with multispectral cameras that go around and take pictures of fields. And then that data is ported into a cloud server with machine learning algorithms that can actually tell you things about the chemistry of those plants, plant health, even recognizing a disease based on some phenotype of a leaf if you take a picture of a leaf and compare it to a database. That's pretty amazing, although I'm probably still not convincing you it has anything to do with chemical weapons. So let's take another try at that. Many of you probably remember in 2005, there were some bombings in London. Some buses were blown up, amongst other things. In the investigative report, retrospectively looking back at what had happened, the room where the bombers were preparing their bombs, they weren't using chemical weapons, but they were using chemicals. And in this stuffy room, they opened the window so that they could breathe and while they were making their bombs. And the chemical fumes went out the window, and it killed the leaves of the plants that were at the level of the windowsill. And people noticed. The neighbors of the house noticed. But nobody really put it together that there's a really unusual pattern of plant disease happening right there across the street. You know, no action taken. Now think about what that means in terms of toxic industrial chemicals, because this is a picture of a leaf that is suffering from chlorine toxicity. And if you talk to people inspecting alleged use of chlorine attacks, chlorine is a gas, reacts and goes away. You can't go and make a measurement and say chlorine gas was used here. There's plenty of chlorine in the environment, and the breakdown product of chlorine gas is more chlorine in the environment. But if you had a database of plant diseases, pictures that could recognize phenotypes of plant leaves, you might actually be able to recognize that something happened. And there's a biochemical reaction mechanism behind this that one could actually analyze for in one of those designated labs with much more sophisticated equipment. So I'm going to end here by ending on the concept of an innovation ecosystem. In startup company world, you talk about innovation and getting people together and getting people from different viewpoints, different interests, different disciplines to share ideas and generate new ideas. And if you only focus them on disarmament, you're probably going to have limited success. If you bring in people from much broader fields and get them to discuss needs and capabilities, you'll have much greater success. And now that I have to end, I will show you one more thing to say that innovation ecosystems, there's no one size that fits all. There's many ways to think about them. In our case, I don't say we have it perfect, but tomorrow I'm actually flying to Brazil because we have a workshop for our scientific advisory board where we actually have some of those people that do agriculture coming to talk to some of the same people that work in the designated labs and work on CBRN response. And I hope we have a report from this meeting at the end of the month, and it would be very interesting to people both within our community and outside of our community. Thank you.
Thank you very much, Jonathan, for that very interesting presentation and also talking about the power of interdisciplinary research to help both treaty verification but also promote peaceful applications of science. Our next speaker is Dr. William Potter.
Thank you very much, Tariq. I see a number of speechwriters for the Executive Secretary in the room here, and what they have learned over time is that, notwithstanding their best efforts to anticipate what he may wish to say, frequently he will appear, toss away his notes, and speak rather extemporaneously. And I think I may follow to some extent his example. First, my old friend Anatoly Diakov, with whom I've interacted for over a quarter of a century, highlighted the joint verification experiment, which was also on my talking point, so I'm going to toss that out of my speech. But secondly, I'm really inspired by Jonathan Foreman's both presence as well as presentation, because I think it is vital when we talk about issues having to do with the Comprehensive Test Ban Treaty Organization. And I see our first Executive Secretary, Ambassador Hoffman, with us as well, pay tribute to him, that we need to talk not only among nuclear scientists. And I think Jonathan today and in the past has kind of pointed out the value of engaging more routinely, more collaboratively, both with other international organizations that deal with weapons of mass destruction, as well as learning from the scientists who are using new tools and technologies in ways that actually may be more relevant than we think to the work of those of us who are more focused on issues of nuclear weapons. I also had some humorous points to make, but I'm going to skip over all of that because much as I like the music that Tariq plays after 10 minutes, I'm going to try to avoid hearing it. And so I'm simply going to suggest that when you think about collaboration, cooperation among scientific communities from different countries and the interaction with policymakers, that it may be useful to recognize three kind of different modes of interaction, and to give you just a few examples from each of those modes, or what, at least in NGO parlance, we talk about track 2 diplomacy, track 1.5 diplomacy, and track 1 diplomacy. By track 2 meetings, which are very common, I have in mind meetings involving individuals who are not formally representing their governments. And I think perhaps the best example of this relevant to the topic of this particular session are the Pugwash conferences, which have been held since 1957. I don't know how many of you are, because I see the majority of the folks here are relatively young, budding scientists and diplomats. How many of you in the audience are familiar with Pugwash? Okay, more than I would have would have gathered. But this was a meeting first held in the town of Pugwash in Nova Scotia, which was attended by some 22 eminent scientists from around the world who had heeded a call by Albert Einstein and Bertrand Russell for scientists and scholars to meet in their private capacities to seek cooperative solutions for global problems, including the threats posed by nuclear weapons. And I think it's significant that that body continues to meet on a regular basis. And in addition to involving scientists from Russia and the United States who have made major contributions to the field, for a number of years you've also had a student Pugwash component. And so for those young people, and I see a number of my former students and current students and other members of the youth group, I would encourage you to see whether your college, university, high school has a student Pugwash chapter, because I think it's a way for you to become engaged in this sphere. There's also the Track 1.5 form of interactions, which involve a combination of government representatives and non-governmental experts. And I think among the most effective forms of Track 1.5 diplomacy are those that both Anatoly and I have participated in the past, involving U.S. National Academies of Sciences and Russian Academy of Sciences, which meet on a regular basis to explore different kinds of issues where there's an intersection between science and policy. I've had the opportunity to serve on a number of these committees, and I've always been struck by the manner in which, even given some difficult political relations between our countries, that the participants in these meetings, high-level scientists, some who've subsequently become, such as John Holdren, the president's science advisor, were able to find considerable common ground, even on sensitive topics. I know, having participated in one, actually on two different committees that were focused on nuclear security issues, having visited probably a dozen different Russian and other post-Soviet state nuclear facilities, we learned a great deal about ourselves as well as our counterparts. We were able to identify differences in terms of U.S. and Russian thinking about nuclear security, the risks that we shared and disagreed with in terms of insider and external threats, the perceived potential for non-state actors to acquire weapons of mass destruction, and the importance of moving beyond the so-called 3 Gs, guards, guns, and gates, to internalize notions of nuclear security, to look at the human factor. And I think these forms of cooperation have tremendously assisted the development of better practices, if not best practices, at both nuclear facilities. And if we have time in the Q&A, I'll relate some interesting experiences that I've had visiting Russian facilities, nuclear facilities, which I think illustrate both certain similarities and differences in our perspectives. Finally, I want to talk just a moment about Track 1 diplomacy, because unlike Track 2 and Track 1.5 meetings, Track 1 diplomacy, which is increasingly rare, unfortunately, today, involves only government officials. The joint U.S.-Soviet verification experiment that Anatoly mentioned was an excellent example of this. The lab-to-lab programs in the early 1990s, about which former Los Alamos director Sig Hecker has detailed so comprehensively in a massive 2-volume study that I recommend to you if you're not already familiar with it, called Doomed to Cooperate. I think they're exemplary case studies involving both Russian and American scientists who illustrate the potential, which may be very relevant to the CTBTO's work today. There also is a kind of made-for-Hollywood tale of post-Cold War intrigue and cooperation set in Kazakhstan in 1994, given the code name Project Sapphire, which involved efforts particularly between the United States, and Kazakhstan to remove some nearly 600 kilograms of highly enriched uranium from a vulnerable nuclear facility at Ust-Kamenogorsk, a facility that was also well known to other players in the region who were regarded with some suspicion by both the United States, Russia, and Kazakhstan. And finally, just to complete my list of some of these examples, there was the collaboration involving the United States, the Russian Federation, and Kazakhstan in a 17-year, $150 million project to seal over some of the test sites in Kazakhstan where several bombs worth of plutonium were buried in the aftermath of prior Soviet nuclear weapons tests which had not destroyed all of the nuclear material present. So these are some examples from the Track 1 sector. I would suggest today that as we look at the need to develop further technical means to promote confidence-building measures at active test sites in the P5, that there may be an opportunity among the so-called P5 process that was developed in the NPT context to identify shared approaches to monitoring tests in order to reinforce the moratorium on the CTBT before it enters into force. And I guess the pardon?
Not ratification.
I would love to see ratification, but I think there are things that can be done prior to ratification as well. The last point I would make, just to illustrate the value of science and the impact on policy, perhaps in a slightly more positive fashion than the film clips that Tariq shared with us at the outset, was the negotiation of the JCPOA. I think it's not simply by chance, as the Russians might say, that the principal negotiators involving the United States and Iran were both nuclear scientists. In fact, they had both received their degrees from MIT. And I think that shared familiarity with science made it much easier for them to overcome some of the political obstacles, and also in the case certainly of Secretary Moniz, to explain the intricacies of the deal to members of Congress who, for the most part, were not particularly well versed in nuclear science. So why don't I simply close on that remark? I'm spared the music from Tariq's iPhone, and I look forward to having the opportunity in the Q&A to perhaps elaborate on some of the cases that I've briefly alluded to.
Thank you very much, Bill, for keeping to the time. As Bill indicated, scientists from the very beginning of the nuclear age realized the potential of the misuse of nuclear energy. And those of you who studied this history would remember that Robert Oppenheimer, when he saw the first nuclear detonation on the 6th of July, 1945, said, "I have become death, the destroyer of worlds." And then 12 years later, President Eisenhower, in his famous Atoms for Peace speech at the United Nations, talked about using atomic energy for peaceful purposes rather than using it for the elimination of humankind. I was struck by the comment that Bill made in his presentation about collaboration between international organizations. And as you know, at the Vienna International Center, the two nuclear international verification organizations, the IAEA and the CTBTO, are co-located, albeit in different towers. And when I joined the IAEA Director General's office, a couple of the safeguards inspectors at the agency who were working on developing new verification technologies came to ask permission to attend a CTBTO technical workshop where they were discussing new technologies for radionuclide monitoring. And in the past, they had been prevented from attending CTBT technical seminars because the member states had said that there should be a non-relationship between the two organizations. And since I didn't come from a bureaucratic and government background, we came up with a solution where we got an NGO to extend an invitation to the safeguards inspectors to sit in a CTBTO technical seminar. And then for the next couple of years, that became the mechanism. But fortunately, or unfortunately, at the time of the Fukushima nuclear crisis in March 2011, the IAEA member states then accepted an offer from Ambassador Wolfgang Hoffmann's successor, Ambassador Tibor Toth, then Executive Secretary, to draw on both seismic and radionuclide monitoring data from the IMS system for IAEA purposes as well. So there is a possibility on scientific cooperation, but nonetheless, it's politics that is still standing in the way, particularly when it comes on the verification side. So I would like now to give the floor to Ms. Sitara Noor for her comments.
Thank you, Tariq. First of all, I want to thank CTBTO for giving me this opportunity to be part of this illustrious panel. It is indeed exciting and rather overwhelming to an extent to share space with such renowned scholars. I want to thank my co-panelists, first of all, for setting the ground for this discussion. We have heard some examples where scientific cooperation actually led to the constructive international partnerships and managed to overcome certain political difficulties and contributed to, eventually helped in strengthening global peace. If we bring this discussion into the South Asian context, there are some good news and bad news. Bad news first. The question is, like, has there been any such bilateral scientific cooperation in South Asia between India and Pakistan specifically? The answer is no. The second question, is there any scope to give space to such collaboration or a political will to allow such positive interaction? The answer is, again, a bigger no. Because in the current political environment between two countries, specifically India and Pakistan, the greatest achievement at the moment is considered the absence of active violence at the border, which is not really positive from the outset. So should this be the fate of the 1/6 of the humanity living in the subcontinent? Of course not. So now let's turn towards the good news, which in some form has been existing in our part of the world as well. It might not be something extraordinary, but it is still good in comparison to the bad news that I just mentioned. And it is at least something that provides hope for positive engagement in future as well. Despite worst kind of hostilities, there had been certain instances where India and Pakistan have collaborated with each other and have entered into some confidence-building measures to reduce hostilities and to engage with one another. As early as 1988, both India and Pakistan had signed an agreement on the prohibition of attack against nuclear installations and facilities, which ensured that both states shall refrain from undertaking, encouraging, or participating directly or indirectly in any action aimed at causing the destruction or damage to the nuclear facilities. Under this agreement, they share the list of nuclear facilities at the beginning of each year. And this long-standing CBM has withstood the pressure of various crises that have come over the years and has emerged as one of the most successful confidence-building measures in the region. Besides that, India and Pakistan have also signed an important agreement on reducing the risks from accident relating to nuclear weapons, which was signed in 2007 and have been renewed since then every 5 years. Particularly, Article 3.2 enumerates that in case of likely impact of accident on the other party, the first party shall inform the other party forthwith relevant information. There is no explanation of what that relevant information is, but particularly considering it involves a nuclear accident, there definitely is the role for the scientific community. So there is scope in this particular agreement that there is need to define the role for the scientific communities from both sides, who in case of need would have an important role to play in determining the nature of the damage and the response efforts that might be needed from both sides collectively or independently. In addition to this, Indian and Pakistani scientific community have worked together under the auspices of various international arrangements. For instance, the IAEA has instituted a program under the CANDO Senior Regulators Group. The group was established considering the unique feature of CANDU reactors. It was agreed that in order to understand the safety-relevant operational and regulatory issues, there should be a specific mechanism and forum for an exchange of relevant information. Under this program, the regulatory bodies of the IAEA member states currently having CANDU-based nuclear power programs, which includes Argentina, Canada, China, Korea, and Romania, besides India and Pakistan, meet annually. Within this setup, Indian and Pakistani regulators have worked and can actually work more elaborately on closely and can share best practices. On safety in general, safety issues in general, there is more open collaboration at the IAEA. And given India and Pakistan's geographical proximity, they need to work more closely, as any nuclear safety incident would have tremendous transboundary impact. Pakistan's Foreign Secretary in 2016 officially indicated the possibility of cooperation on nuclear safety and security if India reciprocates in the same manner. And in the past as well, there had been certain proposals which would have involved greater scientific cooperation, such as establishing joint nuclear power parks in the South Asia, which succumbed to the tensions in the region, but definitely the ideas had been there. And under the SAC, South Asian Association for Regional Cooperation's Technical Committee on Science and Technology, there had been proposals and there had been some offers to collaborate more on the scientific front, but again, nothing substantial was achieved due to the high tensions between India and Pakistan. If we talk about specifically in the context of CTBTO, I think most noteworthy is Pakistan's proposal to formalize the respective unilateral moratoriums on nuclear testing into a bilateral agreement. This may open up ways for both countries to ultimately sign and ratify CTBT and also benefit from IMS data. And since they would start from a bilateral agreement, that would definitely involve more scientific cooperation, more scientific engagement from both sides. And if we talk about collaboration to work together to avert some of the non-traditional security threats that are very much present in this region. During this SnT, there were certain presentations on various other uses of IMS data. One thing that struck me was one such presentation was on quantification of future earthquake hazards in Hindu Kush and Himalaya region by using IMS data, and there was another one on large-scale atmospheric circulation dynamics looking at the monsoon patterns in Indian Ocean. These two areas are of particular importance for India and Pakistan, as they both have faced massive earthquake hazards, and every year they face a flood condition which results in a great loss of life and material. This can be an important collaboration, cooperation for non-traditional, dealing with such non-traditional security threats. I mean, this is one area where there is potential to work forward. So, to conclude, I may say that there are various avenues of cooperation available which might yield immense benefit for the people, but we need to have political will on both sides to reap those benefits, which at the moment, unfortunately, is non-existent. In order to achieve that, I think we need to make more scientific diplomacy an important part of overall crisis management strategy in South Asia. There are regular track-to exchanges and exercises which must include some retired scientists, because officials probably might not be allowed to become part of such debates, who can suggest some technical solutions to some political issues which are there in the region. Thank you.
Thank you very much, Sitara, for pointing out certain areas for nuclear cooperation between the two regional rivals in South Asia, India and Pakistan. With regard to the CTBT, unfortunately, the positions are very different. India opposed the adoption of the final CTBT text at the Conference on Disarmament in 1996. It also removed its name from providing IMS stations, but if you look in the treaty, in the annex to the protocol, which lists countries and the IMS stations that they are supposed to provide, you will find that after Germany, it says to be determined, and that's the slot for India for 2 seismic stations, 1 infrasound station and 1 radionuclide station. The Indian negotiator at that time, in a rage of frustration, declared that India would never, ever sign the CTBT. Pakistanis, on the other hand, are observers to the CTBTO and take part in its discussions but haven't signed. I personally have argued that one should go for supporting a globally negotiated treaty that exists rather than having bilateral agreements or moratoria, which sort of detract from the universality of the treaty, but of course people have different views. So, given the discipline exercised by our four speakers, we have nearly an hour. So please think about asking your questions or comments, and I would suggest if you might kindly refrain from posing a question saying that it's addressed to all four members of the panel, but try and direct it to one or maybe two at the most. We do have a question on the app. Maybe you could put it on the screen and we could start with that, and that might help motivate you to ask your questions or make your comments. So I will need to go closer to this to read. Can you expand this?
Should I read it for you?
Anyone else in the meantime would like to take the floor? There are microphones here in the alleyway. Please, could you kindly identify yourself as well?
Sure, Andrew King, youth group member. This is for Sitara. So the question I have is regarding India-Pakistan relations. So do you find that the scientific community has a hard time distancing their, I guess, the views of scientists from the national government's viewpoints? Or do they tend to view like their counterparts as only being a representative of their national government?
Okay, I would address this question from this perspective, that scientists by nature are apolitical. I mean, that's what science actually teaches you to become a qualified scientist. That's the first thing. But when there are situations where you face countries in a situation where India and Pakistan, definitely they have their nationalistic views attached to them. And then also you need to see how much liberty do they have to exercise their personal willingness to cooperate with the counterparts. So I think that ability to cooperate on the national levels is minimum to non-existent at the moment. But given a chance, I think definitely scientists would work together better than politicians, I think, because that's how they are scientists basically, yeah.
And actually, just to add to that, in the context of the IAEA's various technical cooperation and scientific programs, there is both regional cooperation, international cooperation, and there are scientists from India and Pakistan who take part in scientific collaboration under the auspices of the IAEA.
Terry, can I just add
Yes,
something
please.
to this? This is not as specific to the India-Pakistan situation, but I think there are lessons that are relevant there from the U.S.-Russian experience. I mean, it really is, I would say, heartwarming to listen to the experiences recounted by senior U.S. and Russian former lab directors and other experts who, while they represented very different governments, shared more things than you might imagine in common in terms of their scientific interests. And while it was difficult to initiate the collaboration and the visits, that once they began to interact, they were like little children, you know, sharing their toys, explaining how they, might try new ways to conduct their experiments. But most importantly, and this is where I think it's so valuable that we have the youth group participating today, it was the personal relationships that were established over time that have, to a large extent, endured. And I don't think you can, it may be difficult to quantify for those of you who believe that everything is only valid if you can demonstrate it, its significance in quantitative terms. But these personal relationships play an exceptionally important role. And so I think gatherings of this sort are vital because you begin to establish that network. and to interact over the years, and you begin to share experiences. And so to the extent that we can bring more Indian and Pakistani scientists to gatherings of this sort, I think we begin to set in motion a process which can pay major dividends scientifically and politically in the future.
Yeah.
Can I add, Tariq, just
Yes, please go ahead,
for
Anatoly.
this, yeah. You know that cooperation between nuclear scientists, particularly between Russian and American nuclear scientists, which has worked in the national nuclear laboratories, has some specifics. You know that if there is good relation between the governmental of both countries, so there is no problem in comparisons. For scientists, it seems to me it's pretty easy to establish an understanding and to establish a good contact, and so sometimes they realize that they are doing something very important and can understand each other. But also we need to understand there is some kind of restriction which the legislation of each country has to deal with nuclear activity. And if the relation between governmentals become much more worse, so it's not possible the cooperation between the scientists, particularly which are working in the nuclear laboratories. I am talking about these scientists here, because certainly the contacts between academics, scientists, is not so influenced by the state of relation between government. So we need to understand this also here. And certainly if we, the good relation, good understanding, the personal relation, by the way, between the scientists from nuclear laboratories was established, but it's pretty easy just to destroy this. And we are losing the capital which was accumulated during the previous period. Thanks.
Thank you. Yes, please, sir. Could you take the microphone?
Thank you very much. My name is John Walker from the UK Foreign Commonwealth Office. This is more a comment rather than a question, but it picks up the theme that Bill and Anatoly were alluding to. To give an example, I was involved in the CTPTO's Integrated Field Exercise 2014. And for me, at a personal level, apart from the overall outcome of that exercise, one of the strong features of that was the collaboration, very high collegial nature between the technical, scientific, and other experts from over 50 different countries. Really created a strong bond between all the participants. We were working over 3 build-up exercises. The team spirit was very, very evident, and people were communicating at a technical level. A very strong bond was developed between all the participants. It really was a very impressive performance all round. However, when we took all this kind of spirit back into the policy-making organs, Working Group B, it didn't take very long for that collegial atmosphere to evaporate at the political level. The challenge is always making the connections between the technical work, where you do find collegiality, common ground, a common approach to solving problems. It requires patience, persistence, something I said to Jonathan Foreman this morning before the session started. It requires remorseless patience and persistence to make these things work. And hopefully it will have a trickle-down effect at the policy-making level, which sometimes is completely oblivious to the technical realities. Certainly that's been my experience. So we just have to keep plugging away, would be my recommendation.
Thank you. Jonathan, would you like to pick up on that?
Well, listening to this reminds me of something I heard when I visited CERN in 2014, and I was there for a symposium on science for peace that was part of their 60th anniversary. And they had a number of physicists who had been founders of CERN that had been talking about their experiences back in the 1950s. And at the time, Israel had become a country. The memories of the Second World War were very strong in people's minds, and the policymakers had said that the Israeli and the German scientists could be at CERN, but they should not interact with one another. And the stories that the physicists told us in the symposium was that they would meet every day in the line for lunch, where it was neutral territory. They would design experiments while they were going past the, the food and getting the food on their trays, go to their separate tables, and then go run their experiments in the lab. And they'd meet again the next day at lunch and discuss what they found. And so I think if you think about personal relationships, as Bill brought up, this is no different in politics and diplomacy. It's personal relationships that make things happen. And scientists are very good at building personal relationships because they can find common ground to talk about in terms of the science, and that leads to getting to know one another, finding other common interests. And, you know, I think to pick up on John's point, you know, you really have to maintain this as a momentum. It's great to have these exercises and these meetings and say this is great, but you really have to keep working at making it more visible. And then to make a connection to East Asia, on our scientific advisory board, we actually do have a Pakistani and an Indian, and they seem to get along quite well when we in our board meetings. And also, in regard to the IAEA facilitating scientific collaboration, this is actually one of the ways that a lot of scientists that might come from countries where the countries are putting barriers in place for them to work with, they do work together, but it's usually facilitated by a third party. And it's a really productive way to get people to ease their fears and gain a little bit of trust.
Yeah, it also helps when scientists have a common research project or trying to solve a common problem or collaborating. I saw somebody wanted, please.
I'm Nalin De Silva from Sri Lanka, and I manage the pork station as well as I'm also an inspector. So this is the question to the lady. And if you see the IMS network, there are some gaps in that area due to obvious reasons, and you have to rely much on our data. And again, the India and Pakistan is seismically active area where microseismicity is day-to-day life. So how far you have a cooperation between your two countries to screen out small events, whether just to avoid misunderstanding?
So India and Pakistan, they on the respective sides of the borders, they have their seismic, they have their seismic centers. But I was talking to some person the other day, like, is there any cooperation? Because I don't have personal understanding how much they collaborate. But my understanding is that there is no cooperation or no information sharing on that regard as well. I mean, Pakistani collects on their side of the data and India collects on their side of the data, but when you need a circular information to get a complete picture, which at the moment is not shared between the two states.
Tariq, can I?
Yes.
So I think what's been described is, as best I can tell, accurate in terms of the national postures of the countries. But in the opening plenary, I had a chance to talk a little bit about the potential to exploit new tools and technologies that in many cases resemble and in some instances actually extend beyond the tools and technologies used by the international organizations in Vienna, including the CTBTO. I would suggest that an interesting activity that we might explore among the CTBTO youth group, although this can be done elsewhere, is to gain some experience in exploiting these readily available tools that have to do with the use of seismic data, infrared imaging, geospatial imaging, 3D modeling, and the like, involving Indian and Pakistani youth group members from the Middle East, youth group members from Russia and the United States, and to explore some of the issues that are also challenging issues for the international organizations. I suspect, you can blame this on me because I I think I'm admired by the executive secretary because I tend to be provocative and not very diplomatic. I would bet you that in a reasonably short period of time, youth group members might actually find interesting information that could help in the work of those professionals at these international organizations. Because you can use certain tools and technologies which are not currently being exploited. And as I said in my earlier intervention in the week, it's a false assumption to assume that that which is classified is either accurate or important. And so take advantage of these new tools. You're not constricted or constrained by rather rigid bureaucracies. You can use the newest things that are out there, and there are NGOs and academic bodies in the world who can help you. So I at least plant that seed to see whether you may not, as youth group members, wish to explore this kind of an experiment.
Yeah, I'll add to that. A lot of times, particularly in the bureaucratic organizations, there's a hesitancy to try new things. But if you show that something works and it has really good value in what it does, and people see it, not just hear that you have something that works, but actually see it work, that often goes a long way to changing people's minds and getting them more comfortable with trying something new.
Yeah, just to follow up on Bill's comments, with regard to the IAEA's verification authority, for example, in Israel, India, and Pakistan, 3 countries that are not parties to the NPT, only certain specific facilities are under safeguards. The IAEA does not have the mandate to look for and discuss, for example, establishment of new reprocessing or enrichment facilities in India or Pakistan that are on the military side. So that might be interesting from a research perspective, from an NGO perspective, but that information is not part of the IAEA's legal mandate. And this will not pass muster in the Board of Governors, and the countries themselves will ask, for what purpose are you tracking these activities which have not been put under safeguards? So from a research and information and scientific point of view, that's very useful. And the other concern that has been raised, particularly by representatives of these countries, that now that we talk about risks and threats from non-state actors, putting very detailed imagery of sensitive military facilities on the web where anyone can access them can help potentially those who might be planning to attack such facilities. So on the one hand, we are trying to improve nuclear security, strengthen barriers. Bill referred to guards, guns, and gates. But if for a bad actor, you have all this information up on the screen which tells you how you could plan an attack and breach the defenses to gain entry, that serves a is counterproductive. I saw somebody on that side. Actually, first there's the lady there. Yes, please. You could come up to these microphones. You don't need to. All right, you already have one.
Very kind. Thank you, Mr. Tariq Rock. It's always a great pleasure to see you, and the panel as well. I think the emphasis on friendship
Could
and
you
the role
just
of...
mention your name?
Oh, I didn't. Sorry. I apologize.
Thank
My
you.
name is Deepshika Kumari, and I'm a recent graduate with a doctorate in international relations from Oxford. I just noticed the emphasis on friendships and scientists that can play an important role. And I'm just reminded, this is a comment and follows by a question, I'm just reminded of the friendship that Dr. Bhabha, Homi Bhabha, as known as the father of the Indian nuclear program, had with his friends in Cambridge, which facilitated India's first indigenous nuclear reactor, and the second, which was facilitated by his friend in Canada. And that sort of led to an eventual diversion of India's material to a peaceful nuclear explosion, and then you had the NSU formed in reaction to India's nuclear test. So you also see how sort of friendships can facilitate a nuclear program, for example, in India was facilitated based on scientific friendships. My question then is, there's obviously a great emphasis on the role of scientists, and in a country like India, they have a high influence on nuclear testing. How then can they play a role in delegitimizing the role of nuclear weapons just in general in terms of India's national security when they really don't have a say on what national security means for the country, but they play an important role in defining what would be important for nuclear security or for security of the nation. So do you have any comments on that?
Thank you. I might add that when India carried out its nuclear explosion in May 1974, the then Director General of the IAEA, Sigvard Eklund, wrote a letter to India congratulating India as a developing country for mastering the technology. The letter was intercepted by a policy advisor and was never sent. But Sigvard Eklund was a nuclear scientist, so he was thinking like a nuclear scientist, that from a country that emerged from colonialism not that long had mastered this advanced technology. Anyway, who from the panel would like to respond to that question?
Okay.
Sutara?
I think there are advantages and disadvantages of politically aware scientists, physical scientists. I think in case of India and Pakistan, and this thing was brought yesterday as well, like why there is more influential role in India for the scientific community and it is not in Pakistan. This thing was raised earlier that since Pakistan's security program was completely driven from security concerns, and in response to what India's program initiated first, and then Pakistan responded. So it's more dominant from the security perspective. Hence, greater role for the strategic security community and political less, but more of the defense community in Pakistan side. But in India's side, since there was element of prestige and this greatness that this is they have mastered the technology coming from this non-Western background, and so they from the very beginning they have given a bigger space, and it continues till date. And I think that in a country like India, it's a democratic with a fully functioning democracy. I think this is this needs to be checked, basically, what I mean, because it sometimes goes contrary to what scientists' original role should be, provide some scientific solutions to whatever mandate they have been given by the government, and their role stops there. And then it's the government's prerogative to do whatever they want to do with regards to the security policy or the use of weapons or non-use of weapons or rolling back the nuclear program, whatever. And I think you rightly pointed out, like how to, that's a dichotomy. Like we talk about more communication, but I think if there is more open communication between the scientific community, which I don't see is possible under the given circumstances, but there can be avenues where imagine there is a less securitized environment between the two countries, scientists might collaborate, and they can specifically collaborate, as I mentioned earlier, on certain non-traditional security threats, for instance, to begin with, to sharing seismic data and predicting the monsoon activity, and we face flood every year, so at least we can begin with on that side. But your comment is valid, like it's not on the good terms at the moment. Yeah. Thanks.
There was a question, yes? Oh, sorry, go ahead.
Yesterday, somebody asked me in the talk I gave about the role of civil society, and I think this is where this discussion touches on that, because scientists who are friends are going to share their scientific knowledge, and if they happen to be experts in nuclear energy or nuclear reactions, they'll share their expertise on that. But there's also what is the driving force for scientific research, whether it's coming from a private sector or coming from the government. And I think a lot of what you see in driving directions of science is actually coming from society at large, because there's problems that need to be solved, there's issues that come up. And that's where the civil society comes in, because you can get the scientists to share their expertise on anything, but why are they sharing it? Are they just talking about it to have a discussion because it's interesting, or are they actually talking about it because that's what their mandate is based on their funding source and sort of the motivations and driving forces and all the opportunities presented to them? I bring this up a lot in the Chemical Weapons Convention context, because there's a lot of talk, and I mentioned this yesterday as well, about ethics and science. And I think it works both ways. There's certainly an ethical aspect of scientists thinking about what's the implications of their work, and particularly if their work is based on for harming people. But at the same time, if you look at historical weapons programs, those opportunities that were given to those scientists to create those weapons and do research on those weapons was driven by policy decisions. And I think there's an ethical component there as well.
You want to add something, Bill?
Yeah, if I may. You'll be interested in this too, Tariq, since you were involved. So we talk about collaboration between scientists for good, if you will, promoting disarmament and nonproliferation, But there was a very interesting episode that both Tariq and I encountered in the early 1990s, and it involved a company known as the Chetek Corporation that was comprised of former weapons scientists from a major Russian, actually it was at the time still a Soviet nuclear facility, supported by what is now Rosatom and previously had been their Ministry of Atomic and Energy. And the idea was to make use of so-called peaceful nuclear explosions for environmental purposes. And the idea, to link this to Jonathan, was to dispose of chemical weapons making use of nuclear explosions. As it turned out, there were some people in the US nuclear establishment who thought this also was a marvelous idea. The Canadians were approached, there were glossy brochures promoted. Fortunately, the idea fizzled, but it shows the extent to which, in the interests of pursuing kind of a market mechanism, that sometimes bad ideas also may cross-pollinate amongst our scientists. And the lesson from that I derive is that it is absolutely vital to have a vibrant civil society, to have knowledgeable individuals outside of the government who can express their dismay if they believe that things are awry, such as the use of nuclear weapons, because there is no distinction really between a nuclear weapon and a peaceful nuclear explosion, to address other kinds of major difficulties, such as the disposition of chemical weapons.
That's a good point that Bill made, and actually this was at an event that my center organized in April 1991 in Ottawa. And at that event, Viktor Mikhailov, who was Minister of Atomic Energy at Minatom, brought a team of nuclear weapons scientists from the two major labs in the former Soviet Union, and for the first time to a Western audience, they gave a presentation on how the Soviet Union carried out nuclear tests. How deep was the shaft? What were the containment measures to prevent radioactive gases from seeping out? What were the radiation contamination criteria above the emplacement hole and at the boundaries of the nuclear test site? And there were a large team of experts from the US Department of Energy also attended, but they were in civilian clothes and they sat at the back of the room, and officially they were not present. And as at that event, that everyone was surprised when we were informed that a special presentation was going to be made. And as Bill said, the scientists agreed that from a technical perspective, it was a perfect solution. You dig a deep hole, you dump chemical weapons, you set off a nuclear explosion, and you will be left with a glass ball way down there, 300, 400 meters, and it's self-sealed, and your problem is solved. But everyone else from an arms control perspective was appalled. And also in October 1990, the Soviet General Secretary Gorbachev had actually declared a voluntary moratorium on Soviet nuclear testing, so this also went against it. And finally, a comment. Fortunately, both in India and Pakistan, there are physicists and scientists in the civilian sector, mainly at universities. There's small numbers who are opposed to their respective nuclear weapon programs. They don't get very much space, but on the other hand, neither in India nor in Pakistan have they been shut down, so they can give lectures in their classes to students, publish both in their own countries and internationally, giving a critique as to why these two countries are engaged in a ruinous nuclear arms race. You have somebody at the back there? Yes, please. Mm-hmm.
Hello, my name is Farnaz Alameri. I'm with the CTBTO Youth Group and also with the Middle East Next Generation of Arms Control Specialists. My question is for Anatoly, and I was wondering, could you please elaborate on the 3 points that you were going to make before time was called? I believe you were going to make 3 points, final conclusions. Thank you.
Thank you. So, Anatoly. I apologize for cutting you off then, but you can take some time now.
Thank you. You just give me opportunity to give you my 3 points on the necessity of the cooperation between Russian and American scientists. Yeah, just a second, please. Yeah, let me open my presentations. Okay. So, first is point. I already mentioned about this, but the accumulated valuable and unique experience of cooperation of nuclear issues simply evaporating without communication of the joint vocal specialists of both countries. I can give you just one example, just in support of this. You know, just 1 month ago I spoke with Zik Hacker, who was in Moscow, and he told me that he visited Arzamas maybe 40 times in the previous 20 years. But on his last visit, he has not permission to visit Arzamas again. So he has not opportunity to meet with his friend there. That is just one example. You know that to maintain this accumulated experience, there is a need in just in personal relations. But if there is no opportunity to continue this personal relations, everything is just destroyed. My second point is certainly related with the danger posed by terrorist organizations such ISIS and Al-Qaeda, who openly declared their intention to acquire nuclear and biological weapons. And to prevent this threat, there is a need a real cooperation in the countries on this issue. And finally, both countries, as the two nuclear powers responsible for the global security, must provide to world community guarantees that they are doing everything in terms of fulfilling their obligation on nuclear disarmament and enhancing on the proliferation regime.
Thank you. It's sort of unfortunate that when countries have political problems, one of the first things that they do is to either shut down scientific collaboration with the other side or restrict people-to-people contacts, which actually is counterproductive. It's making the problems even worse by cutting off channels of communication. Other comments or questions? Yes, please. Mm-hmm.
Hello, my name is Angie Carey from the Scientific Implications. So, as I understood, the emphasis is always that the scientific community should collaborate with political diplomacy policies and so on. But the screwdriver who decides how and for which purposes to use the scientific or technological progress is the government. So my question is your point that the scientist has a responsibility for their research, or should they take the responsibility for what they are doing, not for the existing technologies, because unfortunately the atomic bomb was developed, but for the new technologies? So can scientists stop and not give the government actually the new technology? Should they take this responsibility? And as an example, historical example, you can see Heisenberg, that he actually didn't give to the Nazis the atomic bomb, even if he knew how to produce, actually, what was the mass of the uranium. So the role of science in the collaboration with the politics maybe should be turned upside down, so the politics should take the screwdriver and know how to screw it. Okay, this is my question.
So I'll give it to first the two scientists, Anatoly and Jonathan. Who has the responsibility to control emergent new technology and decide that it should not be used by governments for bad purposes?
You? Oh, sure. Well, I think that there's not a black and white answer on that. And I've mentioned this just before. I mean, there's lots of talk about ethical responsibilities of scientists. And on the one hand, you can see why that is, because if you're doing something that you know has bad implications, then maybe you have a moral responsibility to say, no, I won't work on this. But at the same time, life is very uncertain. How science get used, how knowledge is brought together can also be uncertain. You can't predict the future. And there's also a policy perspective. Are the policymakers doing the right thing? Are they providing opportunities to scientists to work on things that might later be used for nefarious purposes? And again, this is where civil society comes in. What's the check, if you will? What's the oversight on what policies are being put into place and what opportunities are being given that drive scientific research? So I don't think it's a scientist's responsibility, policymakers' responsibility 100%. I think there are many people that have to think about this and work together, and it's a discussion that has to happen. And it's not an easy discussion because, again, you can't predict the future, but it really does require active discussion amongst a variety of viewpoints.
Just from very beginning of the nuclear age, you probably know that the scientists immediately understood all dangers related with the nuclear weapons. And probably you know that the American scientists, which was involved in the development of nuclear weapons, provide some information about very sensitive issues to the Russian side, to the Soviet side at that time. Just how to say, because they are understanding all dangers related with the nuclear weapons. And what is important, that they do this just not, how to say, opposite to the government, because the government put restriction on the exchange of information, particularly on all these issues. All activity was covered by the whole security. But scientists decided to provide this information. So they just understood the responsibility, their responsibility of doing such very, to some extent, important work, but at the same time, the very dangerous work.
So I think Anatoly's point, which is now coming out in sort of new history, is that some of these American scientists thought that one couldn't trust only the US government and the British and the Canadians, who were the three governments principally involved in the Manhattan Project with this technology. Bill?
Yeah, I don't think that's, the historical record. In fact, immediately after the Second World War with the McMahon Act, the United States refused to share most of the sensitive information, even with their closest collaborators, the Canadians and the UK. But I think a turning point, and you can argue for good or for bad, was President Eisenhower's Atoms for Peace speech in December of 1953, where there was a major initiative to pare back the barriers and to make available what had previously been classified information to promote the peaceful uses of nuclear energy. What's also not, I think, generally well known is that immediately after Eisenhower's speech, the Soviet Union responded in kind. And so you had this very peculiar peaceful nuclear use race, if you will, in tandem with the arms race, where the governments of the United States and the Soviet Union competed with one another to try to attract scientists from the developing world and from around the world. And so they were sharing information very widely, which led in 1958 to the Chinese demonstrating to the Soviet Union that they were going to pursue a nuclear weapon, which had almost been provided to them by the Chinese. And immediately the Soviet Union tore up all of its peaceful use, nuclear use agreements with its East European allies and imposed much more stringent nuclear export controls. It was a longer period for the United States to derive the lesson that there is really no distinction between good atoms for peace and bad atoms for war. And for them, it was the 1974 Indian nuclear test. The good news from all of this, from my vantage point, is that since '74, at least until quite recently, there has been very close cooperation on nonproliferation issues between the US government and the Soviet government, and then subsequently the Russian government, at least with respect to the issue of nuclear non-proliferation. The real question mark today is whether in our current state of bilateral relations we're able to recognize our common interests in the nuclear security, nuclear non-proliferation, nuclear disarmament world. And I fear that at the moment about the only shared perspective between the United States and the Russian Federation is that they are both equally opposed to the ban treaty negotiations that are ongoing in New York. And I'm not sure that really is the basis for a very viable collaboration as it relates to non-proliferation and disarmament.
Actually, all 9 countries that possess nuclear weapons are opposed to the negotiations on the treaty to prohibit nuclear weapons that's being finalized in New York. Other comments? Ambassador Hoffman, would you want to say something? Over there, please.
I only can say that this was a very interesting discussion, and it reports what I have learned all my life, because that you have to talk together, yet that you have to try to understand each other, and then you can come to a common solution. This is what I learned in diplomacy, but it's the same in science. And therefore, I think what we heard here was very useful. Thank you.
Thank you. So if there are no more comments or questions from the floor, maybe I'll invite the 4 speakers to take 2 or 3 minutes each for any final comments they might wish to make, and we'll start in the reverse order with Sitara first.
Thank you. I think I would follow up from the previous comments that were made and from a rather theoretical perspective that we live in it's a realpolitik all over. I mean, when we talk about certain collaborations, more cooperations, and that war should just vanish in an instant, unfortunately that wouldn't happen because there are so many politically intrigued situations all over the world that it's a complex situation overall. And how the governments function within that, the role of the scientists has been and will continue to be the subordinated one. The scientific advisors can advise the governments, like these are the problems in the use or not use of certain technology. But no state in the end, if we look at the weapons development, no state has developed nuclear weapons with this declaration that we want to destroy the world. Every state has developed nuclear weapons by saying that we are trying to avert war in the name of deterrence, and that's how the existence is continued to, the existence of nuclear weapon is there and would be there for the foreseeable future. And so that brings us back to the whole thing that probably there is need to have solutions which are durable, the resolutions of issues that are there that need to be addressed, and need to end the duplicity of the diplomacy. I mean, at one point, we have the same states talking about non-proliferation agenda, CTBT should be entered into force, and those same states, same representative in the other room would talk about, getting certain states into the fold of non-proliferation, certain arrangements without seeking some commitments on non-proliferation. The case in point is the NSGs, the current debate in NSG. So we need to see through the things more realistically. I think states should end the duplicity that is there in the international politics. We need to address issues in a more realistic way and bring solutions which are actually more realistic.
Thank you. Anatoly?
My conclusion remark is pretty short. It seems to me that really the policy makers, policy leaders of the United States and Russia will resume cooperation and especially cooperation between nuclear scientists, it will be better for the whole world. It will promote such cooperation will promote the entering the CTBT in the force. That's all.
Bill?
Yes, why don't I conclude by recalling a quote attributed to Albert Einstein. And I think many of you know the quote but may not know the context. Einstein was asked, why is it that when the mind of man has stretched so far as to discover the structure of the atom, we have been unable to devise the political means to keep the atom from destroying us? And he replied, it's because politics is more difficult than physics. I would argue that they're both very difficult and that we need assistance from each other. So I think maybe we've taken a step in that direction in this particular panel.
Jonathan?
Well, I can only emphasize what has been brought up throughout the last hour of discussion, and that's the importance of communication across disciplinary boundaries and outside of people's comfort zones. Because if you really want to come up with problems or solutions to problems, you have to start thinking about what will really solve it, and you have to be open to the idea that sometimes the solution is going to create other problems that hopefully are less problematic, which is why you would want to go in that direction. And when it comes to science and politics and diplomacy, you need other voices as well. Science will not solve the problems. It will come up with potential solutions, but they have to be applied in certain ways. And policies that are meant to solve the problems can only solve the problems if they're implemented in ways that really are forward-looking and well thought through. And sometimes being reactionary to things will cause new problems that were unexpected. That's great in an innovation ecosystem, and it's a lot of fun to be in an environment like that. But when you're playing with countries, maybe not so much.
Okay, thank you very much. So I would like to thank the audience for listening to our four presenters, to those of you who had comments and questions. And of course, I would like to thank the four presenters as well. And I believe there's an administrative announcement. Okay, so please remember to vote for the best poster during the coffee break, and this is your last and final opportunity to do so. And submission boxes can be found in the ceremonial saal and at the registration desk. So I would encourage you to vote for the best poster. These people have done a lot of work in preparing the posters, so they would appreciate if you could cast their vote. So I would like, on your behalf, to thank our four panelists for having a very rich discussion today, and thank you all.
Yes.
Oh, thank you. Yeah, but we don't agree.